Imagine regaining control of your body not with wires or buttons, but with nothing more than your thoughts. Sounds like sci-fi, right? But thanks to astonishing breakthroughs in AI-controlled prosthetics, this future is already here. Today we're diving deep into how artificial intelligence is giving people the power to move again, not with muscle, but with pure mind. From reimagining motor function to decoding thoughts in real time, this is one of the most transformative intersections of neuroscience, robotics, and machine learning ever witnessed. The implications stretch far beyond mobility. We're entering an age where mind and machine merge with intuitive precision. Before we continue, make sure to subscribe, tap the notification bell, and like the video so you never miss the frontier of future tech. Welcome to Tech Mythos, where innovation meets imagination and the impossible becomes possible. A new wave of prosthetics is revolutionizing how we define movement. Traditional prosthetics have always relied on mechanical manipulation, manual switches, body motion, or clunky sensors, but AI is reshaping everything. We're talking about prosthetic limbs that can interpret neural signals directly from the brain or residual nerves and translate them into complex movements in real time. The promise is no longer theoretical, it's practical, visible, and functional. These devices are learning not just how to move but how to feel, react, and adapt. They aren't static hardware anymore. They evolve with their users, offering new layers of autonomy. Take the case of Johnny Matheny. He was the first person to attach a mind-controlled prosthetic arm directly to his skeleton. Developed by Johns Hopkins Applied Physics Lab, the Modular Prosthetic Limb, MPL, uses a combination of sensors and AI algorithms to decode signals from his brain, allowing him to control the arm with astonishing precision. He can shake hands, hold delicate objects, and even play the piano, all just by thinking. This was once the dream of science fiction. Now it's an everyday reality for Johnny. And his story is just one among many as the field rapidly expands. Veterans, athletes, and civilians alike are becoming pioneers in a new realm of neurotechnology. How does this work? It starts with a brain-computer interface, BCI. BCIs collect neural activity through implanted electrodes or non-invasive EEG headsets. These devices detect the electrical chatter of the brain as it forms the intention to move. AI algorithms then interpret these electrical signals, matching them to the user's intended movements. The challenge? Each brain is different, and neural patterns aren't uniform. That's where machine learning comes in. Algorithms must learn the language of an individual brain, adapting and improving over time. It's like teaching a machine to understand an accent it's never heard before. Machine learning models are trained on the unique neural signatures of the individual user. Over time, they improve their accuracy by adapting to the user's thoughts and behavior patterns. This adaptive learning capability allows the prosthetic to feel almost like a natural extension of the body. As the model continues to evolve, it begins to respond faster, more accurately, and with greater fluidity, mimicking the intuitive control we normally associate with biological limbs. The more the user engages, the smarter the system becomes. Eventually, users report the device disappearing, feeling as though it's simply part of their body. Let's talk numbers. According to a study published in Nature Biomedical Engineering, a deep learning algorithm trained on BCI data improved movement classification accuracy by over 20% compared to traditional linear models. That could mean the difference between clumsy movement and natural motion. This isn't just theoretical advancement, it's a measurable leap forward in user experience. And this accuracy means more than convenience. It means independence, dignity, and reintegration into daily life. It means going back to work, playing with children, or simply enjoying a cup of tea without assistance. Companies like CTRL-Labs, acquired by Meta, Neuralink, and NextMind are pushing these boundaries. CTRL-Labs uses electromyography, EMG sensors that detect electrical activity in muscles, even when the movement is too small to see. The AI interprets the intent behind those microsignals, essentially reading the electrical whisper before a muscle contracts. Neuralink is going even deeper, aiming to implant ultra-thin threads directly into the brain for maximum signal fidelity. Their long-term goal? Seamless brain-to-machine communication, enabling everything from mobility to memory enhancement. NextMind, on the other hand, focuses on non-invasive EEG decoding, allowing users to control digital interfaces with subtle shifts in thought patterns. Collectively, these companies are building the future of neural interaction. But it's not just upper limbs. AI-controlled leg prosthetics are also gaining traction. Researchers at MIT have developed intelligent robotic legs that adjust in real time to terrain changes, speed variations, and even stumble recovery. Using reinforcement learning, the prosthetics adapt to walking styles, learning the best ways to support balance and efficiency. This makes uneven terrain, stairs, or sudden slips more manageable, restoring confidence and freedom to users. It also opens up possibilities for athletic performance and optimized gait training. We're seeing the emergence of prosthetics that not only restore function, but enhance it. If you find this as mind-blowing as we do, hit that subscribe button, like this video, and share your thoughts in the comments. What would you do with a thought-controlled limb? Would you go hiking, dance, build, or do something you never thought possible again? Would you return to your passion, or invent something brand new? Let your imagination lead the way. Now let's address the elephant in the room: brain surgery. Yes, some of these systems require invasive procedures, but not all. Non-invasive BCIs are rapidly improving in resolution and reliability. Companies like Emotive and Kernel are developing wearable EEG systems that allow thought control with no need for surgical implants. While they're currently less precise, the rapid evolution of AI signal processing is closing the gap. And with each generation, non-invasive BCIs are bridging performance parity with their invasive counterparts. This trend is critical for widespread consumer adoption, lowering both risk and cost. In the near future, having a neuro interface could be as common as wearing a smartwatch. And here's something even wilder. Researchers are working on bidirectional BCIs. That means, not only can the brain send signals to control devices, but the device can send signals back to the brain. In theory, this would allow a prosthetic hand to feel textures, temperature, and pressure, and relay that sensation back to the user. One such study by DARPA showed that participants could distinguish between different levels of pressure applied to a robotic hand. The implications for natural interaction are staggering. We're talking about bringing the sense of touch into the digital realm. Imagine picking up a cup of coffee and knowing it's hot. Imagine feeling the grain of wood, the fur of a pet, or the pulse of another human being, all through a synthetic limb. Another innovation: AI-powered sensory feedback loops. By stimulating specific nerves with precise electrical signals, users can begin to regain a sense of touch in their prosthetics. These systems use real-time data collected from pressure sensors on the prosthetic and send it back to the nervous system, essentially creating a closed-loop sensation circuit. This not only improves function but fosters emotional connection and embodiment. The limb feels like it belongs, not just physically but emotionally. It can lead to lower phantom limb pain, improved motor control, and an enhanced sense of self. This breakthrough is turning robotic limbs into emotionally resonant instruments of healing. The emotional impact of these technologies can't be overstated. Veterans, accident survivors, and amputees are regaining not just functionality, but a sense of wholeness. As one user of an AI-controlled hand told MIT Technology Review, "It felt like I got a part of myself back." Others have reported tears of joy after holding a loved one's hand again, or picking up a musical instrument they once thought lost to them forever. These stories underscore the human element behind the tech. For many, it's not just about utility, it's about restoring identity. The power to reclaim one's story, one movement at a time. Of course, this field isn't without challenges. Training machine learning models for BCI requires massive datasets, and brain signals are noisy and variable. Calibration and adaptation times can be long, especially for first-time users. Ethical concerns also arise around privacy. If a machine can read your thoughts, where do we draw the line? Could there be misuse? Could thoughts be recorded or hacked? These are not just philosophical questions, they're urgent technological ones. Regulatory frameworks and ethical safeguards will be crucial. Public trust in these systems will determine how rapidly and how wisely they evolve. Moreover, access and affordability remain hurdles. These devices can cost tens or even hundreds of thousands of dollars. Insurance rarely covers them in full. However, as with many technologies, costs are expected to fall as adoption increases and open-source projects proliferate. We've seen similar trends with genetic testing, smartphones, and even space travel. What was once elite becomes everyday. Advocacy and innovation must go hand in hand to ensure these advances reach everyone who needs them. Equity in access is not a side note, it's the next frontier. OpenBCI is one such example. They provide low-cost, open-source hardware and software for brain-computer interfaces. Their Galia headset combines EEG with EMG and eye tracking, offering a multimodal way to decode user intent without implants. Developers and researchers worldwide are building on this platform, accelerating innovation through collaboration. This kind of grassroots, democratized tech development will be critical to global adoption. It's also fostering a new generation of neuro-entrepreneurs and citizen scientists. These aren't just tools, they're launchpads for ideas that could reshape humanity. In the next decade, we may see prosthetics that rival or even surpass natural limbs in function. With built-in sensors, AI adaptability, and wireless connectivity, users could customize their limb performance in real time via smartphone apps or cloud updates. Imagine switching between precision mode for delicate tasks and power mode for heavy lifting. Imagine receiving firmware upgrades to improve balance, speed, or coordination, just like updating your phone. The line between body and machine will blur in the best way possible, and with AI-generated optimizations, your prosthetic could even learn your routines and anticipate your needs. And beyond individual users, this technology has the potential to impact remote robotics. Thought-controlled exoskeletons or avatars could allow disabled individuals to work in environments previously inaccessible to them, or even explore space or deep-sea stations via robotic proxies. Paralyzed individuals could control machines across continents. Disaster recovery workers could enter dangerous zones virtually. The potential for inclusion, empowerment, and exploration is unprecedented. We are entering a new era of cognitive mobility, one where thought is the only interface you need. The convergence of neuroscience, AI, and robotics is redefining what it means to be human. We're not just building tools, we're building seamless extensions of ourselves. Prosthetics that read our thoughts and respond with precision, agility, and even feeling. That's not science fiction anymore. It's the next chapter in human evolution, where biology meets digital intelligence and where limitations are not just overcome but reimagined. And this is just the beginning. The age of mind-directed machines has arrived, and its story is only just unfolding. Want to stay ahead of the AI curve? Hit subscribe, like, and turn on notifications. We break the silence around future tech, one myth at a time. This is Tech Mythos.